So yesterday we discussed about the introduction to the embedded networking, and so we seen a lot of topology, like a star topology, mesh topology, and likewise we seen many topology in order to understand how they are communicating. Okay, and as well as we seen the 7 layers, the OSA layers. Actually,
Hello.
those are yeah. Hello, who is that? Okay, listen. If anything happens, just post in the chat box. Whether you can't able to talk, I can't able to listen, I can't hear you. Just post in chat box. Enache, what happened?
Good morning, sir.
Good morning. To tell that you interrupt the class, huh? So yesterday we discussed about that 7 layers. So what are the layers are there, and what is the use of the layer? That is just for the basics. And the embedded system networking uses the major things. One is the port, and another is nothing but the buses. The buses, buses is used to transfer the data between the two devices. So that will act as like it is nothing but a cable, the conductor. So which is used to carry the information from one place to another. And port is nothing but providing the provision in order to make a connection. So here, for example, you're having the LAN port, you're having the USB port, you're having a lot of communication ports. So those are nothing but the port. So buses is nothing but the cables which you are using. So inside the processor, they will tell it as a buses. It is not a cable actually. So inside the processor or inside the PCB board, so there will be a thin strip of metal will be there. So you can able to see if you just Google the any PCB board. So there will be lines will be there. So that are nothing but a small thin layer of the conductor. So those are is called as the buses. Okay, so buses, if it is the bus is fixed in the sense, it will provide the same. Suppose if it is a serial communication, I will use only one bus required, so that I will transfer every data within a single line. But it may take some time. So if I'm using the parallel buses inside it, so at a time I will send 8 bit data, so simultaneously. But thing is, it will occupy more space. So there is a difference between the buses. If it is fixed in the sense, suppose if I'm giving an attachment outside, I can change it. So based upon the length, suppose a projector I want to connect to that computer, the projector is far away means I will use the cable differently. So that's why we are providing the port in order to make the communication. And so based upon that, we will change the type of the port which I'm connecting. So whether it may be a parallel based upon the application. So suppose I want to transfer the data, I will use the USB. Suppose I want to share the my screen. So that also nothing but I'm giving the inputs and getting the outputs. So they are communicating. So I will use the VGA in order to share my screen using the projector. So likewise, we have different provisions in order to share the different data. Okay, and the input output ports. So So yeah, input port. So input port is used to receive the data. So data in the sense they are representing in terms of the bytes. So 8 bit. So from the external devices. So external devices representing the external peripheral, maybe the mouse, the keyboard, or what are the things you are attaching as an input. Otherwise, the processors. So processors, multi-processor, if communicating in the sense, one process will give the input to the another one. Okay, so those are nothing but the input device which is used for reading purpose. So those ports are called as the input ports, and output ports, quite opposite to that one. I want to send the data in order to write it. So receiving is nothing but the reading purpose. I'm reading the inputs, and writing is nothing but transmitting. Okay, so those are nothing but the output ports. And how the ports are connected. So each and every ports having these addresses. Suppose if you are inserting a USB drive, it will read. So it will read first of all. After that, it will display that pen drive along with your name. So already you just rename your pen drive with your name, right? So that way it will be read and that will be projected. And as well as each and every USB device having some addresses. Okay, so that address it will read and the information it will read, and as well as it will scan the memory. So if it is a USB flash drive, in the sense it will scan the memory and it will show how much free space are available, how much it is occupied, what is the total space. Likewise, this kind of information will be read by the port. Okay, and here they are given the examples. What are the input and output ports are available and how they are going to make a communication. So serial interface is there, and serial peripheral interface, parallel peripheral interface, and the ports. If you just remember the 8051, there will be a 4 ports: port 0, port 1, port 2, and port 3. So these ports are connected using this serial interface or a serial peripheral interface. Likewise, and in IBM they're having the communication port 1 and 2. Nowadays we are using the laptop, so there also the communication port are represented using the COM1 and COM2. So these are just an example what are the ports are available and how they are communicating. So here we are going to see the types of port. So previously we discussed what are the types of communication will be there. So similarly, based upon that, the ports also they having the classification. So first classification is synchronous serial input, and second is synchronous serial output, asynchronous serial UART input, and asynchronous serial UART output. And UART is nothing but universal asynchronous receiver transceiver. Okay, and it will act as the both the input as well as the output port. Suppose if you are connecting the USB, it will act as an input as well as output. It not only the reading, it is also writing. You are not copying any file from the USB. You are also writing or storing some file into the USB, so that the same port will be used as input and as well as the output. But in a microprocessor, there will be some pins which will act as only as an input. Okay, so that's why they named it as the serial input, serial and output. And some other devices may have the it will act as an input as well as output, both the functionality it will provide. And types of parallel. So parallel port 1 bit input and parallel 1 bit output, and parallel port multi-bit input and a parallel port multi-bit output. What happened? Guys, can you hear me? Guys, can you hear me?
Yes, sir.
I don't know why this PPTs keep on rotating for me. What about you people? Are you getting the screen clearly?
Yes, sir. Types of parallel port.
I'm trying to change it. It is not changing. Okay, now it's okay.
Sir, MS Power.
So now it is okay. It's working.
Okay,
Parallel port 1 bit input. So 1 bit input in the sense I will take 1 bit input and I will produce the convert the one input into the parallel one. So like serial in, parallel out. So that's why they represent the parallel port 1 bit input and parallel port 1 bit output. It representing I will take a parallel input and then I will produce in bit by bit operations. Likewise. So these are the 4 types, and remaining is parallel port multi-bit input and multi-bit output, like a parallel in, parallel out. So I will get the bulk of data at a time, as well as I will produce the bulk of data out to the output. Okay, so these are the types of parallel ports. Let's see the serial port one by one. So synchronous serial input. So they given some examples for the processor, the data transferring from or reading from the CD, the hard disk, the audio input. Like I told, the peripheral devices. With what are the things you are connecting to your laptop? So everything is there given here, like a CD, hard disk, audio input, video input, and dial tone. So dial tone is nothing but internet call and internet network input, transceiver input, so scanner, etc. So these are the just an example for the synchronous serial input. And if you see, so this is the diagram. So how the serial input ports are available. Uh, if you see here, there will be two inputs. One input is nothing but the I0 to I7. That is nothing but the data which I am going to give inside, and another input is nothing but the clock signal. Okay. So synchronous serial input device. So first letter representing the synchronization. Synchronization representing I'm going to send the data along with the clock pulse. So remember, what is the synchronization is nothing but I'm going to send the data along with the clock pulse. First clock pulse. During the first clock pulse, I will send the first bit, and during the second clock pulse, I will send the second bit. Based upon the clock timing, I will send the data. So that's why they named it as serial. I mean synchronous serial input. And if you see, the inputs are sent one by one serially. Okay, so that's why it is named as synchronous serial input devices, and that D0 to D7 representing the address. Okay, so this is the basic diagram for the synchronous serial input device, and the synchronization is nothing but I'm going to send the data along with the clock pulse. Keep on remember, don't forget about this one. So they will ask what is the synchronization, what is synchronous serial and asynchronous serial communication. So on the time you have to represent. So synchronous communication is nothing but I'm going to, sending the data along with the clock pulse. So the data speed will be represented in terms of the clock pulse. So clock pulse means one clock pulse how much time it take. Suppose it is taking t seconds, and your data speed will be 1 by t seconds. Sorry, your data will be 1 by t. So you will represent in terms of bits per second. So the time will become in denominator. So that's why if you're reading the data speed in your mobiles also, it will tell 10 mbps, 2 kbps, 3 kbps, etc. likewise. So thing is, the speed will be represented using the how many bits I'm going to transfer for 1 second. If the time clock cycle time is t, in the sense that the speed will be represented using 1 by t. Okay. So here they're representing the serious synchronous serial inputs. So like I said, they given the definition. The sender along with the serial bit also sends the clock pulse. So that's why they represent the serial clock, SCLK, representing the serial clock. So to the receiver, and and one clock pulse how much time, so that is representing using the t, and I am sending one byte, so one byte representing the 8 bit, so total time taking is 8t. So what will be the speed? So speed will be 1 by 8t. So what is the time period? So that will be divided, so that I will calculate the speed of operation. So here in the last point, they're representing speed of operation, the receivers rate, the constant rate. So it will be constant always, it won't vary. Okay, so here they given an example, 1 bits per second is equal to 1 bit for 1 second, representing for a 1 second operation, I mean 1 second of duration, I will send only 1 bit. Okay, and serial data and clock pulse input. So there will be a relationship between the serial data and the clock inputs. So I won't make any delay to the data which used to send. So similarly, like I said, so along with the clock pulse, each and every clock pulse, along with that, I will combine with the data, so that it will be go in same time duration. So there won't be any delay, so that the speed of operation will be very very faster, and as well as the data will be sent one by one because it is a serial communication. And after receiving the data, what it will do in the sense, it will do the decode operation. So I told that it will be combined with the clock pulse. I want the data only, not to write it. So what it will do, it will do the decoding process in order to split the clock pulse along with the received data. And how it will received, so based upon the clock pulse, suppose if I'm sending the clock pulse, it will take at middle of the clock pulse, it will change. So otherwise it will be a positive edge trigger, negative edge trigger. So what is a positive edge trigger? I think you studied in digital electronics. Did you remember what is a positive edge trigger and negative edge trigger? Hello. So what is the positive edge and negative edge? Guys, what is positive edge? What is negative edge? What is positive and what is negative edge?
Sir, never mind.
Okay. Can you able to see the
Sir,
screen?
whiteboard, sir.
Yeah. I only changed. Mm, it's not showing the photos. Whiteboard open ಆಯ್ತಾ? எனக்கு இங்க ஓபன் ஆகல.
Yes, sir.
எனக்கு black screen-ஆவே இருக்கு.
Loading இருக்கு black.
Okay.
எனக்கு அதான் சார் இருக்கு.
Whiteboard open ஆயிருக்கு sir.
ஓபன் இருக்கு. எனக்கு இங்க ஓபன் ஆகல.
இப்போ ஓபன் ஆயிடுச்சு.
Let me see.
இப்போ ஓபன் ஆயிடுச்சு சார்.
But I can't find any option to write.
Sir, மேல பென்சில் பாருங்க sir.
இல்ல என் ஸ்கிரீன்ல வரல. பிளாக்கா இருக்கு.
Open ஆயிருக்கு sir. Black pen.
Black pen. For me it is not loaded fully. I don't know. Um, it's not visible. Right. Actually, positive edge clock pulse will, for example, one clock pulse having the positive and negative, right? I mean, the one representing the uh, oh, okay. Whiteboard, if I use it, won't be recorded. So error message is showing. Whiteboard will not be recorded. Support for recording whiteboard is coming soon. So that's why it is not showing to me. Why? Because I'm recording that.
Sir, but வேற class எல்லாம் record ஆகுது sir.
Record ஆகுது. But here it is showing like this.
Infinite teachers இருக்கு sir அது.
Whiteboard. Microsoft Whiteboard or a freehand by Invision board. Okay. All right. Okay. I will share the PPT. Actually, so far I shared the PPT using the team app itself, so that I can't able to write. So otherwise, I will share the PPT by opening in my laptop, so that I can able to write. So that is a problem. So usually I used to share the PPT from my laptop. Today what I did, I just uploaded in the team and then I opened using online. Let me share. Is it visible right now? Is it visible, guys?
Loading like this.
Yes, sir.
One sec.
So here I can able to use. So this option is there. Here I can use the pen instead of using the whiteboard. So clock pulse, it will be like on and off. So this is the one clock pulse. It's representing 1, and this is the 0. And again it will keep on repeat, right? It will be like this. Okay. So what is a positive and negative edge trigger? So positive edge is nothing but here you can able to see actually in this time period it won't be neither the 0 or 1. So it will be in both condition. So once it reaches that maximum, after that it reaches, right? So this is called your the positive edge, so which is going from a 0 to 1 condition. Okay, and negative edge triggering is nothing but from the higher value to your lower value, so negative edge. So this representing the negative edge triggering. Okay, so sometimes while sending the clock pulse, whether I want to identify uh, along with the clock pulse I am sending the data. So suppose here the data is uh, whether it is a 1 or it is a 0, 1, and again it is going 1. So this is another time period. Let me draw. Okay, so this is the data. So here I will write the data for one clock pulse. I am sending the 1 bit, and second clock pulse I am sending the another bit, so that is 0, and from here to here it is third clock pulse. Okay, from here to here it is a third clock pulse. Right, on the time I am sending the 1, as well as for the fourth clock pulse also I am sending the 1. So I am sending the bit 1011, 4 bit I am sending for an example using the 4 clock pulse. Okay, so while sending, whether when I want to recognize the data, so whether I want to recognize the data at middle of your clock pulse. So middle of the clock pulse is nothing but this is a one-off cycle, and so this is a one off cycle, and this is another off cycle. So middle in the sense in between. Okay, so total time period is 0 to t means 0.5 t. So on the time I will recognize, I will check the data. Okay, it is showing the high voltage. I will consider the received data is high, likewise. And again I will check at the middle of the option, and I will check it is 0. Likewise I will check on the middle of the clock pulse. This is one type. And another type is I want to recognize the data based upon the positive edge. So positive edge means at this time cycle I will recognize whether on the time what will be the amplitude level, high or low. And suppose if it is a positive edge, in the sense at this point of view I will check, and second input I will check in this point, and third input I will check in this point. Similarly, if it is a negative edge means when it is coming down, so that one on that time only I will recognize. So based upon that I will recognize the data. And here in a serial input there will be two mode of operation. One is a master output slave input, and a master input slave output. So nothing else, so master slave two will be there. So master representing giving the command, and the slave representing always accepting the command from the master. So it is you study the master slave flip flop, right? Master slave flip flop, did you study, did you remember?
Yes, sir.
Yeah, so there will be two logic circuit will be there. So two flip flop will be there. So first flip flop representing the master, and second flip flop representing the slave. So what it will do, the master first it will give the command to the slave, what to do. and it will accept the input from the slave also, but majority of the authority will be for the master. So similarly here, from where I am getting the input and output. So suppose the master is giving something, in the sense it is providing some output, and it will, otherwise it will take the input from the slave. Okay, so here if you see the first one, the master output slave input is uh, the serial clock is sent from the sender to the receiver, and the slave is forced to synchronize. Okay, so the clock is sent from the sender to the receiver. So which is sender here representing the master, and slave is accepting. It is accepting the input. So that's why it representing the slave input. In order to make the slave to force to synchronize for the input. Okay, and if you see the second condition, it will quite opposite. The sender will be the slave and the receiver will be the master. So on the time it is taking the input, I mean the master is taking the input from the slave, but slave is forced for synchronization. So synchronization means adding the clock pulse along with the data pulse. Okay, so these are the two things. So here in serial asynchronous serial inputs, I am using this two methodology. So whether the slave is always forced for the do the synchronous operation, and who is getting the input from whom. In first the sender will be your master and receiver will be your slave, but in the second case sender will be the slave and the receiver will be a master. So only main thing is synchronization has to be done. And so this is the synchronous serial output device. So first we seen the input device, and this is your output device. And here if you see always there is a default address will be there, data address will be there, and if you see the direction will be in outside direction. Always the clock is given to your output, and as well as the data is given in output. So here what I will do, I will send the data outside. I am not accepting, I am not reading, I am going to write. So whether I am going to write to the memory or I am going to sending to the any other peripheral devices. So what are the output devices are connected in your laptop? Can you tell? Output devices,
The
display and
printer,
printer, yeah,
um,
and
USB cable also is like output device.
yeah, I'm sending, but only output. I'm not taking it. Only output.
Mhm.
So headphone is the output. I mean the
Yes, sir.
speakers are output.
Yes,
Microphone are
sir.
input, and what are the other things are there? Nothing else. An HDMI cable. I used to connect to the display, right? HDMI.
Yes, sir.
So those are nothing but the outputs. So here, so due to the synchronization, I will combine. I mean, I will send the data based upon the clock pulse only. So that is the difference between the input and output. But remaining operation are all same. So here I am sending out. In the previous case, I am accepting. I am receiving in. Okay, so that is the difference. So here they are given some thing like writing a CD or disk and audio inputs and outputs and video input output and the dialer output. So everything is applicable for here also. Why? Because CD I am not only reading, I am writing also, and the hard disk also I am reading and writing, and the audio I told the speaker audio representing the microphone and the speaker. So speaker is nothing but the output and microphone is input. So generally they are represented here as audio input and output, etc. Okay, so here how to calculate the time period. So based upon the clock pulse t, that speed will be calculated by 1 by t bits per second. How many bits I am transferring for 1 second? Okay. And synchronous serial output using shift register. And you know what is the purpose of shift register? In order to send the data one by one. So if it is a shift register, it will send the data at particular I mean based upon the clock pulse. Did you remember the shift register?
Sir,
So what it
stable
will
in.
do, so if suppose if it is a 4-bit shift register, 4 flip-flop will be connected together, and at the first clock pulse, the first flip-flop will generate the output. Okay, and at the second clock pulse, that output from the first one will move to the second flip-flop, and similarly it will take the another bit from the, let me draw. I don't know whether you people are imagining or not. So this is one flip-flop, and here one more block. So I will draw 4-bit inputs. So how it is sending the data serially? So it will be only one data in and one data out. And here I will give the clock pulse. And there will be two synchronous and asynchronous shift registers are there. Here I am doing the synchronous, which is works on the common clock pulse. Asynchronous is output of the register will be given as a clock of for the next bit. Okay, here this is synchronous one. So everything, every clock is connected to the single clock, and this is the clock. Here data will be there, and it is connected to here. So I am using the D flip flop, and this is your data output, and this is your input. So here what I am doing, I am going to give the first input. So totally series of input. Just consider 1 and 0, 1 and 1. Okay. So after giving the first bit, so here it is LSB bit is nothing but the first bit, this one. Okay. I am giving the first one here. So on the time the first clock pulse is given. So far there is no process happened here, and during the second clock pulse it will, I mean D flip flop is nothing but what are the inputs you are giving, it will reflect same, only act as a buffer. So one clock pulse delay. So during the second clock pulse what I will do, it will process the output as 1, and during the second clock pulse I will give what is the second bit also 1 I am giving. So again it is 1 I am giving, so that, and after the third clock pulse this one will move to here, and the second input will come to in this place, and at the fourth clock pulse I am giving the third bit 0. So here it will give the 0, and on the time at the fourth clock pulse what will happen, this will move to here, and this one will move to here, and the 0 will move to here. Likewise, based upon the next clock pulse the output will keep on shift. So this is how it is moving serially. Okay, so at fifth clock pulse I will give the last bit, and everything will be moved. So at the end, at the data it will become here it will be 1, and here it is always 1, and here it is 0, and here it is 1. And if I give the sixth clock pulse, it will be moved to output, and again this position will come to here. So this is nothing but your shift register. Okay. And so next is synchronous serial input and output. So both will be there. So here you can able to see, here I'm having the output buses with both the directions, so input as well as the output. So address will be there, and clock I have to give. Why? Because it is a synchronous one. So why? Because it's a synchronous one. And here if you see, there will be a difference of duplex serial input and output, full duplex serial in and out. So what is the off duplex and what is the full duplex? So off duplex representing I'm having only one bus, either I will do the transmission, otherwise reception. But here we having okay. So this will be input now, so error mark will be in this direction, it will be in this direction. This is not actually it's wrong. Okay, so I naught is the input, I will receive the data, and this is output O0 to O7. So that is the output. I will send the data at simultaneously. So here only one bus, so at a time I will come or I will go, like a single transmission. Here there will be two buses are there, so that what I will do, I will send or I will receive at the same time, so based upon the clock pulse. Okay, so during the sending operation, here if you see the clock I will send out, during the receiving operation I will take the clock pulse. That is the difference between this. So here I will use the off duplex mode or full duplex mode. Okay, so this is meant for serial input as well as serial output communication and synchronized one. So again about the the time period, they how to calculate the time period, and So everything is here common here, already discussed. And if you see the second one is a different communication, asynchronous serial input and received at UART, universal asynchronous receiver transmitter. So communication port. Here if you see, you can't able to find the clock signal. So I'm not going to send using the clock signal. I told another methodology, like I will send the data as a packet one or framed one. So data will be there, and along with the data I will send the start bit, and in order to show the end of the data received, I will make the stop bit, and if I want I will add the parity bit in order to check any error occur or not. So here I am having the transmission and reception, and these are nothing but the control signals. No need to explain about this. So DCD, DSR, everything is nothing but the control signals. Okay. So at what time I want to start the communication and what is the address I'm going to receive it. So everything will be given in this here. So these are used for controlling control signals. Okay. So it does not have required any clock pulse or clock information, and each bit is received in each byte at fixed interval, but each received byte is not a synchronization. So I told that there is no synchronization, so there is no clock signals and all. And so byte will be separated by variable intervals or phased difference. So how I'm going to separate the byte one data. So suppose I'm sending 10 8-bit data. Okay, so I will send one by one by making some duration, some interval. So here it is not, we can't able to tell the speed of operation using bits per second. Why? Because I'm introducing some delay, and as well as the data only I'm not sending, I'm sending the data along with the start bit, stop bit, parity bit, everything. So we can't able to explain in terms of the speed, like mbps per second, bits per second, likewise. So here they will represent using the baud rate. Okay. Yeah. So this is the format of the bit at UART protocol. So protocol I told it's nothing but a set of rules I'm going to make in order to transfer the data or receive the data. So if you see here, if I'm sending the 8-bit data, I'm going to send that in terms of 10 or 11 bit. So what is that additional 3 bits or 2 bits? So 2 bits surely will be there. That is nothing but the start bit as well as the stop bit. And if it is 11 bit representing one more bit I used for parity bit. Okay. If you see here, the first one is nothing but your start bit. Can you able to see this? Yeah. So here it
Yes,
is
sir.
nothing but the start bit. So that I am representing here. So always while initiating any communication or I am initiating to transfer the data, first I will send the start bit. Along with that start bit, I will send the 8-bit data 1, 2, 3, 4, 5, 6, 7, 8. So this 8 is nothing but the data. So I will send the 8-bit data, 16-bit data, 32-bit data based upon that. Here for an example they given 8-bit, and afterwards I send the parity bit. So this checked one is nothing but a parity bit. It's an optional, I can send or I don't want to. If suppose I want to check the error, I will send the parity bit, and at the end of the session I sending the stop bit. So this is the format for asynchronous serial communications. For the input as well as for the output I will use this format. Here if you see, I told that we can't able to express in terms of bits per second. Here they will use the baud rate. So baud rate representing how much, I mean how many frames I am going to send for one time cycle. So here starting point of the receiving, the starting point of receiving the bits from each bit is indicated by the line transition from 1 to 0. So what it here representing is the line transmission 1 to 0, how many times it is changing the ones and zeros. So that they are going to calculate from the time period. And and if you see, I told that if suppose the 8-bit data is transferring at the time period of t, in the receive it will take 10t or 11t. So what is 10t representing? Actually 8 time period duration. 8t is used for 8-bit data, and additionally the 2-bit start and stop bit, and additionally the periodic bit. If I include it, means totally the 11 time duration I required. And if you see here, they are using the 8-bit shift register in order to receive that the 10-bit or 11-bit. So initially it will check the output. So first a start bit will come. It will represent I'm going to the data is along with me. So this is the initiation of the transmission. Okay, so after that, so that will be occurred at 0, and after that the 1 to 8 will be representing the 8-bit data, and the 9th and 10th will be representing the stop bit. So sorry, parity bit, and after that stop bit. So once it detecting the stop bit, after that it will close the port, so it won't allow any communication. So again it will check, wait for the next session of the transmission. So again whether any start bit is coming or not. Suppose sometimes any error occur, means the frame will be breakdown, so that instead of the 8-bit data, 4-bit data is combined with the stop bit, in the sense it will start the it will write the data from 1 to 4 only. So once it is received the stop bit, after that if any data is coming also it won't recognize. So always it will recognize the start bit first, after that it will check the data. So that is the process here. Yeah, so here discussing the same, so asynchronous serial output. So this is for output transmission purpose. I'm going to transmit each byte with a fixed interval along with that start and stop bit. So there is no clock intervals and all. So again and again they are telling the same here. So minimum separation is one stop bit interval. In the sense, if I'm sending the multiple bits, so first I'm sending the first bit, and then I mean first frame and second frame. So in between I may have only one time period. So one stop bit interval only I may have, so that I send continuously. I will send the sequence of data continuously. And so I shown one protocol, right? If you are sending using that protocol, and that is called as UART output, so for transmission purpose. If I am receiving the data using that protocol, it representing the UART input. So that is the difference between the UART output and UART input. So universal, you don't forget, UART representing universal asynchronous receiver transmitter. So this is the protocol where they are using for all the communication if they are transmitting in asynchronous manner. Okay, and asynchronous, so they given some example. So output from modem, output from printer, the output on a serial line is also called UART. So modem under works under universal asynchronous synchronous receiver transmitter. So that is the only thing main. And one more thing is printer. So why it is not work? Can you able to anyone give the justification why the printer cannot be used in a synchronous input or a synchronous output printer? Why it is representing in asynchronous? Why the printer comes under the asynchronous example? Why it is not in a synchronous example? Anyone? So previously I told the laptop working very high frequency 2.9 gigahertz, and the printer cannot able to work at that frequency. And I told in a synchronous I will send the data based upon the clock pulse. So clock pulse representing the speed of operation. It will be very faster. and it will send the data very faster based upon the clock pulse, but the printer cannot able to. So that's why I'm using the asynchronous, universal asynchronous serial receiver transmitter. Okay, so that kind I'm using here. So that's why the example for the serial asynchronous output is printer, and as well as the modem also. So modem data rate may vary, it won't be a constant one, so data rate will maybe vary. So I'm using the modem as the example for serial asynchronous output. Okay, and again half duplex. So you know what is the half duplex? It is a bidirectional but communicating at once at a time, so we can't able to transfer or you can't able to receive. And full duplex, so it's doing the receiving and transmission at simultaneously. So that is a full duplex one. And so we'll see this parallel tomorrow. It's very simple one. So after that we will start the protocol, serial communication protocol, we will start tomorrow.